Earth systems concepts. What is a system? A system is just an ordered, interrelated set of things and their attributes linked by flows of energy and matter that is distinct from the surrounding environment. And for all practical purposes in Earth systems science, all systems are open. It's just a matter of degrees. Some systems are more open than others. System feedback, which is of great interest in geography because there's a lot of complex things that happen in environments. System feedback is when outputs influence continuing system outputs via feedback loops. An example of this one is ice albedo feedback. Now, albedo just means reflectivity. So we could call this ice reflectivity feedback. Here's how it works. One of the things that's been noticed in observation, going back to the scientific method, observation has been that the Arctic zones have warmed up more than the other parts of the Earth for the most part. So why is that? So there's a process that describes that. And one of the processes that describes why the Arctic is warm more is ice albedo feedback or ice reflectivity feedback. What is going on is this. As the Arctic has warmed a bit because of the increased carbon dioxide in the atmosphere, what would that do to the amount of ice in the Arctic? Well, this isn't difficult, right? So even your elementary school kids, if you say, hey, if you make it warmer, what happens to the ice? And the students say, the ice melts. Okay, so there we go. So melting ice in the Arctic because of warmer temperatures creates a feedback process, because now that we have less ice on the ground and less ice on the oceans, instead of having a highly reflective environment, one where much of the incoming solar radiation ends up going back out to space because it's reflected off that ice. Now that we have less ice, the surfaces are darker, aren't they? If they're darker, then what is the influence of that darkness or darker being more dark on their reflectivity? It's kind of like wearing on a hot summer sunny day, a sunny hot summer day, wearing a white t-shirt or a dark colored t-shirt. Which one is going to make you feel hotter if you're out there in the sun? We know the dark colored one. By the same token, in that environment, losing the ice, having a darker land or more transparent, darker water, more absorbent water, ends up absorbing more of the total solar radiation. If you're absorbing more of the solar radiation, what's going to happen to temperature? It's going to rise. Okay, so that is exactly what's happened. So a warmer temperature because of more greenhouse gases creates a positive feedback loop where ice melts, making a darker colored environment at the surface, absorbing more sun, and making it warmer, which melts even more ice. That's what we call a positive feedback. So the second concept here is system equilibrium. When rates of inputs and outputs are equal and amounts of energy and matter and storage are fairly constant. This is perhaps most easily illustrated with the global climate system. For the most part, we can say throughout history, there's always been fluctuations to some degree in climate, although we've had a relatively stable climate history in the last 10,000 years. And that's almost certainly one of the reasons that allowed human civilizations to advance so much, whereas in previous times, they advanced so little. We spent most of the time hunting and gathering up to that point. So what's happened? So as we, in the last couple hundred years, have been putting more fossil fuel emissions in the air by burning coal, we are warming the planet. And what that means in terms of system equilibrium is the system is a bit out of equilibrium, because what we've done is we've trapped more of the Earth's heat with those additional greenhouse gases, and we've caused the planet to warm. And when that happens, the storage part, see how that word storage is in the very bottom line of that last part of the slide? We're now storing more heat. Where is it going? Some of it's being stored in the land. You can measure down in the Arctic 20, 30, 40, 50, 60 feet deep. It's warmer. They have these boreholes where they've been recording that for a long time. The subsurface area of the Arctic is warming. The oceans, absorbing 90% of all that excess heat that's being trapped in the atmosphere, is going into the oceans. The oceans are warming. Okay. So we have now increased the amount of thermal energy in storage, as well as increased the amount of heat still in the atmosphere as measured by the temperature. Okay. So the system is now out of equilibrium. It's changing as we continue to put more greenhouse gases in. Now I'm having trouble getting this stopped here, so at some point I'm going to get it stopped. Here we go.